Excellent. So I'm Pete Goldsmith, and tonight I'm going to present Melting a CI Snowflake. I'm a lead mobile developer at REA. I've been there just under 2 years. Before that, I was at ASOS in London. And before that, I was at Itty Bitty Apps for nearly 5 years. So I've been around Melbourne for quite some time. At REA, my day job is looking after mobile tooling, focusing on the kind of entire organizational set of problems. So for this presentation, I'm going to run through how at REA took multiple ways of doing iOS CI and moved them to the same tooling that the rest of the organization was using and the benefits that we've been seeing. I'm going to cover what we had in the past, what we've now got, how we're using Mac Stadium and why we went with them, how we manage multiple Macs in Mac Stadium, the challenges of managing macOS build environments and why putting macOS in a box is a good thing, so that's virtualization, and how all of this hangs together in our new system. All right. So iOS tooling, or Xcode, needs to run on Macs. No Docker, no AWS, no Linux, and certainly no Windows. From this spawns all the complexity that you see time and time again in different organizations. At REA, it's been no different. We have had so many challenges in the past of iOS being the snowflake child that sits off in the corner. Even Android, doesn't have these sort of problems because Android can run on Linux and can be put in a box. At REA, we use Buildkite for the entire organization. Android is orchestrated using Buildkite. All of the backend, front end, everything is using Buildkite at REA. And REA has been using Buildkite for many years. And with such a large investment into Buildkite, we've built up expert knowledge and some really incredible internal tools and auditing and security processes that make using Buildkite just an absolute dream internal to REA. However, iOS didn't get to reap any of those benefits, couldn't tap into any of the great sides of using Buildkite. Because iOS is such a snowflake and the friction of trying to align anything process-wise that we're doing with iOS and Android, that friction just built up more and more over time, and iOS as a CI kind of got forgotten, and ops people would just ignore what the iOS mobile people were doing off in the corner. And yeah, we've gone through quite a few iterations at REA of holding CI. This little table that you're looking at here is kind of a snapshot of where we were before we kicked off this initiative about this time last year. We have quite a few different apps, quite a few different internal libraries and frameworks. This table is not exhaustive, but what it's trying to show here is that we had the PR builds or the unit tests were being run on Buddy Build for the Red app, but the App Store and archive builds were being run on laptops or Mac Minis somewhere in the building. Another app and another team had everything on a Mac Mini, another team had everything sitting on Buddy Build. And every time a new app or a team was spinning up, these sets of problems needed to be solved over and over again as to which tool that they should be using. And we were using Buddy Build quite happily until Apple bought them and then shut down the Android support and then stopped accepting any more money to scale up. So we started to hit a point, like a real inflection point for we really wanted to solve this problem and solve it properly internally for everyone, not just for one of these teams or one of these apps. For the laptops and Mac Minis that we had floating around, one of them was a laptop that was responsible for doing the archive builds and uploading to the App Store. It occasionally got cleaned up or put away by cleaning staff. So we had to put some Post-it notes on it, but we put 2 Post-it notes on it, so there was some redundancy there in case someone knocked one of the Post-it notes off. We had another team that was using a Mac Mini that we just like. I asked, so I can see that you're using this particular build machine. Whereabouts is it? Like, it's definitely not in our data center that REA is moving out of. And a lot of the members on the team didn't actually know where in the building it was. They said it's somewhere near, the tech services people. And yeah, there was a day where I needed to chase multiple people to tell me other people that actually knew where this box was physically located in the building. So yeah, that's a bit of a snapshot as to where we were. We had some laptops under desks, laptops on desks, some Mac Minis hiding in cupboards. At one stage, we had a trash can Mac Pro that was on display in our kind of like tech hub area where we would let guests and clients kind of walk through. But that Mac Pro was on display, but it was actually our build server for a period of time. And yeah, we had fragmented usage of Bodybuild as well. So this time last year, we came up with a plan, and what we wanted out of a solution was that we really wanted to leverage everything that the rest of the organization was reaping benefit-wise from Buildkite. So we wanted to use Buildkite for our iOS pipelines. But doing so, we didn't want to just grab a couple of Macs and put Buildkite agents on it and force everyone onto the same tool chain, because we had such a large number of teams and different apps, and all of those had different Xcode version requirements, dependency managers, Carthage, Cocoa Pods. No one was using SwiftPM. There was 83.7 different versions of Ruby being used across the organization. And our task wasn't to unify everyone onto the exact same tool chain. Our task was to give our teams the autonomy and the ability to choose their CI infrastructure similar to everyone else was within the organization. So that was getting to choose their own tool chain, choose their version of Xcode. And previously we had been burnt where we had put Buildkite agent just sitting on a Mac. And that ends up with a bit of onus on the people using that infrastructure to be aware of the fact that they're running on a persistent machine. We didn't want that. And another problem that we had previously was when we were managing our own Macs was the time to new Xcode version was quite important, especially when betas are coming out fast, or when Apple gives you 24 hours to get ready to upload to the App Store. We wanted our time to new Xcode less than 1 week, and we achieved it less than 1 week. We can meet Apple's demands of 24-hour turnaround. So, like I said, using Buildkite means using self-managed Macs. For those that are not familiar with Buildkite, and I've been talking about Buildkite, it's a CI, it's a platform as a service that offers the orchestration of your pipelines, and they give you a little Buildkite agent, which just accepts your commands, and you put that Buildkite agent on a machine somewhere. Most of the time, that little machine is inside like a Docker image on AWS or some other kind of infrastructure vendor. But it's a tiny little agent that takes requests in from Buildkite Cloud and runs them on the environment that it's hosted on. So like I was saying before, we could have just purchased a handful of Macs and put them in the office, but then that spawns a whole bunch of other questions that we really didn't want to have to answer. We were moving out of our data center that REA had been in. We didn't want to rapidly start moving back into a data center. And luckily, there is a mob who specializes in offering up Macs that are in a data center that meets all of the security and uptime requirements that we were after. So that's MacStadium. And MacStadium, they rack mount consumer grade hardware. They rack mount Macs. They rack mount iMacs. 5K iMacs rack mounted are quite hilarious. I don't have any pictures of those, but here are some pictures of thousands of Mac Minis being rack mounted. And there's a Mac Pro that is a little bit pricey for us right now, but so using MacStadium, we were able to solve and get answers to all those questions. We didn't have to worry about power. The network uplink times the no cleaner was going to come by and accidentally bump a cord or anything like that. Another great thing that we could do with MacStadium was guarantee a kind of a secure communication between REA's network, and REA's got a very, I'm not a network guru, but the internal REA network's wired up like many other enterprises, lots of different access controls. But what MacStadium offers is that we can, from MacStadium, rent a dedicated firewall appliance and have that create a direct encrypted peer connection with the REA's firewall. And through that tunnel, I can talk to the Mac Minis as though they're on the machine next to me in the office, or now that I work from home, it's kind of the same as talking to Macs over the cloud. But you know, it's all the same internal REA access controls. So you have to be authorized onto the REA network first before you can talk to any of these Macs. These Macs can talk outwards to the greater cloud, but I should have deleted some arrows because they can't actually they can't initiate connections back in to REA's network. So that's MacStadium solving the physical infrastructure problem. Now we can kind of turn to the software on the Macs. Looking after any machine that's going to be persistent has, you know, its perils. And for build machines, for a very long time, Docker and other virtualization technologies have been solving this for everyone else. We had tried in the past, like I said, physical Mac with Xcode installed on it and the Buildkite agent, but then that becomes a great big ball of state really quickly. If you went up to your security or ops folks and said, hey, we're going to run a CI agent process on a Linux rack server, we're going to give it elevated privileges without any containerization, and we're going to let anyone in the building run arbitrary commands on it, you're probably going to get an interesting response. So yeah, looking after an Xcode or macOS build environment is quite tricky. And when we needed to service multiple versions of Xcode on the same machine, it can be done, but you start to hit iOS simulator stability issues when you've got multiple versions of Xcode installed and they're all talking to the same iOS simulator core simulator service. Things start to get flaky. So what we wanted was ephemeral build environments, just like Docker. So that means getting macOS, virtualizing it, and putting it in a box. There are different technologies for doing this. VMware is one of the great virtualization vendors, and there's VirtualBox, which is open source. I think that's still by Oracle, and there's Anchor. At the time that we were looking at these different solutions, Anchor stood out for us. So on the slide here, there's a little alien. That's the Anchor logo. So yeah, Anchor is a virtualization tool that focuses solely on macOS. So unlike VMware or VirtualBox that are kind of trying to solve virtualization for many different guest operating systems and host operating systems, Virtue, the company behind Anchor, they are dedicated to just solving virtualizing macOS on macOS. And having that kind of tight focus means that they can offer up a tool that's extremely fast and works with all of kind of Apple's intricacies. Also at the time when we were evaluating different vendors, they were one of the only ones that were built on top of Apple's hypervisor framework. And what that meant was, because we wanted to use the 2018 Mac Minis, the 2018 Mac Minis have got a T2 chip, and the T2 chip is kind of the secure gateway to some of the internals of the Mac, such as the SSD. And if you were a other vendor at the time, other vendors' hypervisors with their custom kernel extensions were not able to access things guarded by the T2. But as of now, I think most vendors are now offering solutions that do work on Apple's hypervisor framework. But still, I'm very happy with Anchor as a vendor who solely focuses on the kind of problem domain that we wanted solved. Anchor as a tool doesn't have any UI. It's all kind of command line. It's all command line infrastructure. And in our quick testing, we were able to get a reference VM. So we put macOS and Xcode build, Xcode inside a VM and put that in a suspended state. We're able to clone that VM, run Xcode build within it, and tear it down within 10 seconds. I'm very happy with that. So with Mac Stadium solving our physical infrastructure problem and using Anchor to solve our virtualization and software problem, I'll now cover what our setup is, or what we ended up building. This here is a quick dashboard of that Gina from REA, who worked with me on all of this stuff that I'm presenting tonight. She built this dashboard that shows the running agents on our Macs. So we've got 8 Mac Minis at the moment in Mac Stadium, and each of them are running 3 instances of the Buildkite agent. So any one physical piece of metal can run 3 jobs at the same time. The 3 it started out as an arbitrary number, but it's worked out to be a decent balance trade-off of number of concurrent jobs and hardware utilization. So yeah, on this dashboard, you're seeing the yellow Buildkite is jobs currently being built. And yes, I will now cover how this system kind of hangs together, or how that kind of works end to end. So this is a diagram where we've got 8 Mac Minis sitting in Mac Stadium, and the cloud at the top, that's the Buildkite platform as a service. So if we zoom into one Mac Mini, we've got 3 Buildkite agents. When each of these Buildkite agents have got a different priority level, so that guarantees uniform utilization of the hardware. So each Mac has got a priority 1, and then a priority 2, then a priority 3. That just means that if 3 jobs come in, they're not all going to the same physical machine. They get distributed across all of the hosts. So when a job comes in, it's going to be executed by one of the Buildkite agents on the metal machine. Buildkite offers a hook that we can run a script in, and at this point in time, we can kind of do some tasks before the actual request of the build job. This is the bootstrap script. So the first thing that we want to do is we're going to clone a VM for the job at hand. So like I was saying before, we've got these kind of template suspended VMs, and inside of these VMs, we've got Xcode already installed, Homebrew installed, Ruby, a bunch of different Ruby versions, and CocoaPods, and a few other gems and command line tools. Ignore the 11.4, that's old copy and paste that I did. So we clone that for that specific build job that's come in. So that we now have a new warm running VM that is got a ID, like it's got a name that references the build ID. The next thing that we do before the job starts is we install certificates. So the VM templates that we've got floating around don't have any secrets installed. Those are deployed to the physical Macs, and they get injected into the VMs after they're booted. So we run a few keychain commands and install a few other environment variables. We then pass the job from the outer metal machine inside the VM. So once that happens, the job inside, that little Buildkite agent that's sitting inside the VM, has no idea that it's running inside a virtual environment, and neither do the consumers of our CI. They just write in their pipeline YAML the tasks that they want to have done, and what jobs that they would like executed, or if they've got any Buildkite plugins that they would like to run. And that runs as though it's running in a metal machine. Once a job passes or fails, we kill it. So we kill the VM that we made just for that build, and we go back to where we started. So doing that process over and over again, every time a build occurs, we can guarantee that we've got the same immutable reference image that is used for a particular build. So making this work. Managing metal is something that was new to me. I had done previously, way back, a little bit of Linux administration when I was working for a domain name and web hosting company, but I was not really at the time in charge of looking after metal machines. For the metal machines that we've got up and running, we've got quite a few tasks or things that we need to have installed on them, or provisioned, and keeping all of them uniform and keeping all of them in the same shape and updated to the exact same tool chain is something that you don't want to write a bash script for. You don't want to SSH into each one, or you don't want to VNC or screen share into each one and try and make them all the same. There's a tool called Ansible that is dedicated to this job. Ansible excels at managing persistent mutable infrastructure, and it's got this concept of a playbook or tasks, and when it's running these tasks, it can do all of these optimizations to check if it actually needs to run a task. So you can say something like copy a file from this or location to this location, and it checks first if it's already there. If it's already there, it's not going to do the task at hand. It's got a very strong focus on idempotency. So making sure that if you run the playbook or your tasks multiple times, it's going to end up in the same state. And yeah, it was a bit of a learning curve using Ansible, but once I tried to do anything like what it was achieving in Bash or in any other scripting or tool, yeah, fell in love with it. So the host metal machines that we've got, they don't need Xcode because nothing's built directly on them. All that we when we need to add a new metal machine, all we have to do is update an inventory file. So Ansible runs on this concept of inventory, and it's just a text file with IP addresses or host names, and we just add a new one in there, and then I run the playbook, and it will run against all of the machines, and it will make sure that they're all uniform. And provisioning a new piece of metal is quite fast. It doesn't take that long. Building VMs or installing Xcode or unpacking Xcode zips does take a long time. We went with a shape of one version of Xcode per virtual machine. So that means that for all of the versions of Xcode that our system supports, there's a different virtual machine image for each one of those. Different vendors have gone with different approaches, but what I was focusing on in this case was how quickly could we go from nothing to a VM that we could use in our infrastructure. So installing Xcode, like I said, takes a really long time, and priming the simulators takes a long time as well. So if we were to have all of our versions of Xcode in the one VM reference image, to go from nothing to that, if I had to do disaster recovery, would take a very long time. So the list of tasks, I'm not going to go into great detail here, but these are the list of tasks that we run through to go from nothing to a virtual machine image that is good to go. All of these tasks take very significant amount of time. Installing macOS from base takes 40 minutes. It's not too long, but unpacking or downloading Xcode and unpacking it, and then booting the simulators and priming them. So when I say priming the simulators, if you've installed Xcode from scratch and you've opened up the simulator for the first time, you see the Apple logo in the booting bar. That's writing out a whole bunch of files to disk and setting up that little simulators environment. We do that inside our virtual machine images. So anytime someone starts a build, they don't have to wait for that overhead. So all of this takes a really long time. And one of the ways that we cut down on this is we layer this. So we have one image that is just got the macOS installer complete in it, and that's the base image, and that kind of gets used as a reference. We then take that reference base image and we build the tools image. So that's Homebrew, Ruby, all of the versions of Ruby, all the other command line tools, and that I call the tools image. And then we go from the tools image to the Xcode image. So this is the thing that happens a lot more frequently, and especially after wwdc. That's where we take the tools image, we download Xcode into it, we unzip it, we run the command line options for first time launch, we boot the simulators, and a few other little things after that. But going from the tools image to the Xcode image takes about an hour and a half, and then to copy that image across the entire machines, across all of the machines, that total time's about an hour and a half. So our time to new Xcode is a lot less than 1 week now. So what does it look like to use this system? So if you're a iOS person at REA now, you get to write your CI pipeline just like everyone else that's using Buildkite. You specify your steps. The only thing that's slightly different is that you do specify an environment variable, the macOS VM name, and that helps us when we're bootstrapping to tell us which Xcode version or which VM image you would actually like to use. The other thing is that you specify which agent queue. So that's mobile CI in our case. And that's all you need to do to get up and running with our infrastructure. And in this example here, we've got 2 tasks. They're both running concurrently. We've got tests, and that's running on mobile CI, and we've got the archive application. So the command is what gets executed inside the VM. All of Buildkite's plugins work and are compatible with our setup. What trying to highlight here is it's a bit of YAML and it doesn't show a lot of value, but from where we were and the friction that each team or app had to go through to set up a new project, or buddy build where all of the CI configuration was not codified, it was not in the repo itself, it was all ClickOps, it was all in a web UI. The speed for us now to grab a new project and get it onto our agents is the friction's completely gone. So some of the benefits we're seeing, like I said, really fast to get up and running. Infrastructure as code. So previously when we had the Macs ourselves and had installed Xcode and tried to set up a CI environment, none of that was really, because we didn't have the virtualization technology. Or the virtualization technology we did have wasn't as scriptable as Anchor. We've now got infrastructure as code. So if our Mac Stadium data center got wiped away or Pete got hit by a bus, I keep walking in front of buses, but they're not that hard to come by these days. In London, there's lots of buses. It's easy for us to get up and running again, to build out, to deploy this infrastructure again. Because of all of the existing Buildkite expertise within the building, I wasn't going to go too much into Buildkite's feature set, but the kind of parallelization and consolidation of artifacts that you can do. You can do some really fun things, like you could have one step build your testable artifact and then deploy that to 6, 7, 8 other concurrent steps with a different flavor of a simulator environment or a Xcode toolchain. So we do have one project at the moment, which is a SDK, and they're at the same time they're parallel building using Xcode 11 as well as Xcode 12, and that was just one extra step in their pipeline file. And to be able to do that, which was not even possible with our previous setup or with Buddy Build, has definitely made a few teams happy. I didn't highlight at the beginning, but I'm very keen for lots of questions. So I've got one more slide where I'm going to go through references, but if you've got questions, hit up to Slack and Tups will ask them to me in a second. So references, a lot of the information for doing iOS CI is scattered around all over the place. There's lots of different blogs, there's lots of different Slack channels, but there's not, like, Apple's official documentation doesn't give you any guidance on how to do this. Like, I think a lot of it still references Xcode bots, which, that was a fun time. So there are a few places that I always keep going back to. Bitrise as a vendor, they are amazing at what they open source. Their open source repo has 100% of their infrastructure for how they build their VM images. And that has got lots of really great nuggets in it for faster ways to accept certain dialogues for certain permissions that you have for certain first-time launches of certain tools. All of these weird things that you hit when you're trying to do this stuff for the first time. And it was recently shared on the Cocoa Head Slack that GitHub have open sourced some, not all of their macOS stuff. What's really fascinating with the GitHub VM images is that they put all of the versions of Xcode into one VM image. And I was looking at it, they've got 13 different versions of Xcode that they need to install into one VM image. It must take them so long to build that thing. And that happens in a single run. And Mac Stadium, their repo as well, has got lots of really good stuff. I didn't mention Fastlane in this presentation, but Fastlane, the source code, has got lots of great nuggets if you are in this space and you are looking at managing iOS simulators. So yeah, that's the presentation. I'm Pete Goldsmith. I'm very keen for lots of questions. I'm at _Pete Goldsmith on Twitter, and you'll always find me on the CI/CD channel on Slack at Cocoa Heads. I've got notifications turned on for that one. So yeah. Tups, you got any questions?
Yep. Thanks, Pete. So it's probably one of the advantages of the current COVID situation is the hit by the bus situation is probably a lot less likely than it was before. But we do have a couple of questions from the Meetup channel, which is great. The first one actually came from Matt Dells, but Matt Coles wanted to know as well. So you've got all the Matts wanting to know. Updating the VMs, and I think you covered it a little bit there at the end, for new betas and Xcode versions.
Yep.
What sort of process do you go through for that?
Yeah, so to build the VMs, I'm using I'm using Ansible as well, because a lot of the tasks that need to run on Metal are the same that happen inside a VM. So I have a playbook which takes these, or builds all of these images from scratch and tiers them up if they're not already available. So the question was, what happens when Xcode betas get released? So
yep.
when an Xcode beta gets released, the initial step is currently still manual. Like, I run Ansible on the command line. I do some clicky clacky. I run a script, but that then goes and talks to all of the, well, it goes to one machine, which builds the VM image, and then it then pulls it down and then deploys it across the rest of the machines. Yeah, if there's anything specific, more specific than that, I'm happy to answer.
Yeah, and I assume that you stay pretty much with the latest sort of release of macOS. You're not running into the betas of macOS just to make your life tricky.
Yeah, no. So for macOS, this I didn't really emphasize too much. The shape of everything that we built is very much tailored and suited to REA's sets of problems and benefits that we see. If you were wanting to look after, like if you were building a macOS app and you wanted to try and do this, then you hit another world of problems, because if you want multiple versions of macOS at the same level that we've got multiple versions of Xcode, then yeah, you're in another world of pain. So we use the metal machines on, I think they're on Catalina, and the VMs are on Catalina as well. Yeah, I never touched the beta versions of the macOS. There's no, because we're not building, in our organization, we're not building macOS apps. I'm fortunate that we don't need to solve that problem.
Yeah. Cool. I think we've got a heckler in the crowd. Stu Gletto was asking, did you measure the performance of the improvements compared to hosted CIs?
Measure the performance?
Yeah. Or performance improvements.
Right. So I enjoy racing Bitrise for the time to new Xcode version. They've bet me a few times, but I beat them most often. As far as the build performance versus the hosted vendors, ours is much faster. I don't actually have a concrete metric that I can refer to, but because we are controlling the number of competing virtualization instances on the metal, and our utilization is not super high, our speeds for our virtualized environments are, I think, 10-15% knocked off of what it would be to run on bare metal. And yeah, some of the other vendors like BuddyBuild or Bitrise, BuddyBuild were hurt. No, this is live stream. Previously, I had some challenges with BuddyBuild where it was obvious where lots of jobs were starting to pull up, and you could just tell that when lots of jobs pulled up, all of your builds were getting a lot slower. That it seemed to be that for particular accounts, they would aggregate your builds to the same hardware, and it didn't seem like for all of their customers they were being uniformly distributed across hardware. So yeah.
Cool. Sam Jarman asks, what would be a good way to do sort of the dev staging production environments, and the is that just something that you do in your scripts, or is it do you have specific VMs for it?
So for the dev staging environments, I'm not too sure if that's referring to the dev staging environments of the apps or...
yeah, I think so.
Right. So the apps is the teams that make the apps get to choose how they get to roll whatever they want to do for their dev environments. Something that we do have that I didn't cover, one of the benefits that we've been able to unlock, this is another system that the amazing Gina built, is the internal REA App Library. And the REA App Library, because we've got access to an enterprise account, we get to have enterprise internal builds of all of our apps, which means that we don't have to worry about ad hoc provisioning profiles or device IDs. We've got our own AWS hosted behind a REA security infrastructure app library that our CI can directly deposit its artifacts into, and that means each team can spin up a new app and download it onto their phones very quickly. And that's what we use for our internal testing.
So just a quick one related to that. Baz asks, how do you decide what goes to test flight and or prod?
That's the choice of the team. I'm just here to hold the CI. There are different teams that are pushing each build of master to test flight. There are other teams that manually unlock the pipeline, or only certain release branches are automatically going to test flight once the builds are in test flight. We don't have any teams that are going to levels of automating pushing out to the people yet. It's still my understanding, Stu might be able to correct me, we've still got people going into App Store Connect and clicking the button to do that final push out to the public.
Cool. Well, speaking of Stu, he had another question for you. Good. Would you recommend using this approach in any company, and where would you use it and where not?
Thank you, Stu. Proper intro and outro slides would have been good. So like I was saying before, this is very much an REA shape kind of solution for REA set of problems. This is way overkill for very small teams. I think anytime, if you've got one team or one app, and at that stage or at that scale, regardless of contributing devs, you can kind of get away with managing, because you've got the one tool chain to look after. You're probably on the side of it's okay to bear the costs of managing Xcode sitting on metal machines and not have to worry about the virtualization problems. But as soon as you're in an organization where you'd like to have multiple apps or consider multiple tool chains, regardless of you going to these lengths, going with a vendor or rolling your own that allows you to choose your Xcode toolchain quickly and promptly is recommended. GitHub Actions are great. Bitrise is great. For us, like I said, we had so much invested into Buildkite, and where this approach would work somewhere else is you're a company that's super invested into TeamCity, and TeamCity, you could have all of your own same kind of wins if you went with the same approach.
Cool. And I think you might have just answered this one only seconds ago. Bok had a question about how does it compare to insert your opinionated favorite alternative here in terms of CI and those sort of tools.
Yep. So like I said, I love Bitrise and I'll continually recommend them at certain stages. But Bitrise might not be the sensible choice if you've got internal security compliance issues, like if you're a bank or you're a financial institute, and maybe you need, like, you're by compliance required to look after your own metal, then something like this will work. If you can get away with using a third-party vendor, and maybe you're a small startup and the whole organization being on the same CI is not something that you want to is not something that's super important, and Bitrise is a great option. But GitHub Actions is a contender as well, or something to consider. I had a lot of high hopes for when they launched, but I've seen a few things that have raised a few eyebrows, and as far as their time to new Xcode version hasn't been ideal, and I've witnessed a few times where I've hit retry on a build and I've received a different Xcode version, like in the beta period, and hit retry again and I received a different version of Xcode again. So I think there's a few things that they're still trying to iron out. Anytime that you can go with a vendor that focuses very much, like their entire business model focuses on your problem space or the tool chains that you're using, I always say lean towards that. Like Bitrise focus very much on mobile, and Anchor, if you're doing your own virtualization technology, focuses very much on the macOS problem.
Cool. Mike has a question. Has there been any major upgrade pains along the way, and what tends to need the most care and feeding?
That's a really good question. Upgrade pains. So I've been fortunate that there hasn't been any breaking pains when Dub came along. I was like kind of excited for Xcode 12, but maybe they'd change the entire command line interface for the first time launch. But I was able to point the initial build the VM script at Xcode 12, and it all just worked. So haven't had issues there. One of the disk space is a problem. That's one of the hardest things to keep an eye on. We've now got metrics and reporting and AWS sitting on all of the Macs to keep an eye on and fire off alerts if disk space is running low. But if I wanted to support, 13 different versions of Xcode, we then have to solve a disk space kind of problem as well, because if we went with the shape of one VM per version of Xcode, and one of these VMs is like 60 gig, and we wanted to have 13 of those, a 512 SSD isn't going to cut it. We then have to start asking MacStadium for their network attached storage appliances, and then we've got some shuffling around the VMs kind of problems. But yeah, so disk space is one of the things that we kind of knew we're going to hit it as an issue, but when we hit it, I wasn't expecting to hit it as quickly as I did. So there was some quick things that needed to be looked at.
Cool. Couple more questions, and we'll wrap it up. Matt asks, is there any free alternatives to Anchor?
Yeah, so I think VirtualBox is open source and VirtualBox is free. The success rate that you'll have with VirtualBox, I've had lots of failures with it in the past. I don't know what its current status is. Like I was saying before, VirtualBox's kind of primary shtick is not macOS hosts for macOS guests. It does have that compatibility, and you can do that with VirtualBox. And if you just want to toy around with some of this stuff, I'd definitely recommend going down that path. But yeah, there might be other free alternatives as more and more people start to build on top of Apple's hypervisor framework, which is going to become more and more important as Apple Silicon comes about. So other than VirtualBox, I'm not aware of any others.
Yeah, and a nice segue there for you. Mike had a question about what is the plan for Apple Silicon?
No plan at the moment. So Anchor have been internally testing so they've got the dev kits, and they have got internal success with Apple Silicon, macOS being guested or virtualized on Apple Silicon. But yeah, I don't have any plans there. If Apple release a quarter of the price and 8 times the speed kind of Mac Mini machine that MacStadium offer up, then I'll be jumping on board. But I don't know, every time I read the Xcode release notes, it doesn't look like Apple Silicon machines are yet the kind of build environment you want to be sitting in.
Yeah. And we'll call it the lucky last question. Neil asks about, does the solution allow for local only, and local being either Australian hosted or where you host the devices yourself internally?
Yep. So we could, and when I was building this, my laptop was one of the machines. With Ansible, you can just point the inventory at something else and it will run the entire play and it will become available. Like the way that Buildkite works is that the Buildkite agent advertises itself, it phones home to base. So we can be Australian. Mac Stadium don't offer an Australian data center. So if we wanted to put stuff in Australia, we would need to be looking after the physical machines ourselves. But yeah, there's nothing stopping us from that. And I could have a disaster recovery kind of solution where there's a Mac Mini sitting somewhere in the office that is the, break glass failover machine in case, someone desperately needs to ship to the App Store and use our infrastructure.
Cool. Well,
cool.
Thank you very much, Pete. And
no worries.
I think there's a couple more questions in the Meetup Slack there, but there's also quite a few people chiming in with their own opinions as well. So I'm sure that discussion will go on for a little bit longer.